All right, let's crack open the Internet of Things. You hear about it all the time, but how does it actually work? We're going to find out by following a single piece of data on its epic journey, all the way from a physical sensor to the cloud, to really understand how these massive, smart systems are built. I mean, think about it. All around us, right now, billions of devices are constantly chattering away. Your smartwatch, your car, giant machines in a factory. They're all talking. But what are they actually saying? And who are they talking to? So let's make this super concrete. How does one little piece of information, say the moisture level from a sensor buried in a farm field, somehow make its way across the country and pop up on an app on your phone? That's the exact journey we're going to trace step by step. So, to really get a grip on this whole thing, we're going to follow the life of that one single piece of data, from the split second it's created to the moment it becomes a genuinely useful insight. And our journey starts at a place they call the edge. Okay, first stop, the edge. This is such a cool concept. It's basically anywhere the physical, messy, real world meets the digital world. It's the front line, and it's where our piece of data is officially born. Now, no matter how complicated an edge system looks, a smart thermostat or a giant industrial robot, it always, and I mean always, boils down to three basic functions. First, it has to sense the world around it. Then, it processes that information to make a quick, on-the-spot decision, and finally, it acts on that decision, actually doing something in the real world. Sense, process, act. That's it. So that sensing part, that's the job of a sensor. You can think of sensors as the system's eyes, ears, and, well, all of its senses, really. It's the little device that detects something physical, like temperature, motion, or pressure, and turns that into a digital signal that a computer can understand. Okay, so that digital signal zips over to the controller. The controller is the local brain of the operation. It grabs the data from the sensor, runs it through some pre-programmed logic, and decides what to do right now. For example, if the soil moisture is below 30%, then what happens next? Well, that brings us to the act step. The controller's decision gets sent as a command to an actuator. The actuator is the muscle. It's the part that does the actual physical work. It could be an electric motor opening a valve, a pump turning on, or a solenoid moving a lock. It turns a simple electrical signal back into real-world motion. So our data has been created, and it's already been used to do something useful right there on the spot. But for that data to be truly valuable on a bigger scale, we've got to get it off the device. And this brings us into the fascinating world of machine-to-machine or M2M communication. Okay, so our little data point officially exists. That's great, but right now it's completely trapped on that one local device out in the field. So the big question is, how does it get out? How does it begin its journey to the wider internet? Well, there are really two main ways this happens. On one hand, you've got a centralized model. Here you have lots of simple devices that all talk to a single local gateway. Only that one gateway has to connect to the internet. This is perfect for something like a smart factory with hundreds of sensors. On the other hand, you have a decentralized model where every single device has its own direct internet connection, like all the smart plugs in your house connecting to your Wi-Fi. This is way simpler for just a few things, but it gets pretty messy and expensive when you scale up. Now, the next choice is a big one. What kind of local network are you going to use? For our sensor out in a farm field where devices are spread out and have to survive for years on a tiny battery, you'd absolutely use something called a low-power wide area network, or LPWAN. The data rate is super slow, but the range is incredible and it sips power. Now for your smart home, where you need fast, real-time responses over a much shorter distance, you'd use something you already know, like Wi-Fi or Bluetooth. It's all about picking the right tool for the job. Success! Our data has navigated its local network, made it to an internet connection, and is now at the on-ramp for the global superhighway. But just like any highway, you can't just drive however you want. You've got to follow the rules of the road. Think of it this way. For all these different devices and servers made by different companies all over the world to actually understand each other, they all need to agree to speak a common language. In the tech world, this language is called a protocol, and it basically standardizes how data gets packaged up and sent across the internet. Now, in the world of IoT, two models are super popular. On the left, you've got HTTP REST. This is the exact same protocol your web browser is using right now. It's a simple request model. A device asks for something and then waits for a response. It works, it's flexible, but it can be a bit heavy for a tiny battery-powered device.
But on the right, you have MQTT. This is a super lightweight and efficient subscription model designed from the ground up specifically for this kind of work.
So let's quickly look at how this MQTT thing works, because it's really clever. A device, which we call a publisher, doesn't send its message directly to another device. No, instead, it just sends its message to a specific channel, kind of like a chat room, called a topic. That topic lives on a central server called a broker. Then, any other app or device in the world that has subscribed to that topic instantly gets the message. It's an incredibly efficient one-to-many communication system.
And just like that, our little data packet, speaking fluent MQTT, has traveled across the internet and arrived at its final destination, the cloud. You can think of the cloud as the massive, central, digital brain of the entire IoT system. This is where the raw data gets transformed into actual intelligence.
Now, once it's inside the cloud, our data gets sent through what's called a data pipeline. It just got generated out of the edge, right? Now it arrives at a messaging hub for processing. This is where it gets sorted, routed, maybe even cleaned up a bit. Finally, it lands in its long-term home, a database, or what's sometimes called a data sink, ready for analysis.
Now, how that data gets processed really depends on the urgency. For something like a critical alert system in a factory, you need real-time processing. You have to analyze that data the very instant it arrives to get an immediate response. But for big picture stuff, like trying to spot maintenance trends over several months, you can use batch processing, which just chews through huge volumes of data in scheduled chunks, maybe once a day.
And this is where the real value, the real magic, gets unlocked. The cloud doesn't just store data, it analyzes it. It can do descriptive analytics to tell you what happened. It can do predictive analytics to forecast what will happen. And it can even do prescriptive analytics to suggest what you should do about it. This is what triggers those automated alerts or paints the beautiful dashboards that humans use to make decisions. Okay, let's take a quick pause. We followed this tiny piece of data all the way from a farm field to a massive data center. So what? Why go through all this trouble? Let's talk about the payoff, the reason this whole journey actually matters. See, our data's long and complicated journey finally ends when it becomes information that a person can actually use. It might show up as a single dot on a graph in a dashboard, it could trigger a critical text message alert to a technician's phone, or maybe it becomes one data point out of millions that helps an AI model make a smarter business decision. Ultimately, it doesn't matter if we're talking about your fitness tracker, a connected car, or a fully automated smart factory. This fundamental path, from the edge, across the network, and into the cloud, this is the blueprint for how data is making our world more connected, more responsive, and a whole lot more intelligent.
So we've seen the entire blueprint, from a physical sensor all the way to a digital screen. This architecture, this whole system, is incredibly powerful. So now that you know how it all works, what would you connect?